Hey everyone, section 13.2 today. We are going to review a lot of information, quite frankly. A lot of it is going to be reviewed. There's not going to be a lot that's pretty new. We'll get to some things that are a little bit different maybe in section 13.3, but we're talking about linear equations here. So a couple things we have to remember, and I give you guys a blank copy of this so you guys have access to all of this. You guys can go ahead and fill this out. When we're finding slope, it's the change in your y over your change in your x. When we're talking about slope, if slopes are parallel, they're the exact same slope. If they're perpendicular, they are opposite reciprocal slopes. So if your slope is 2, the perpendicular slope is negative 1/2. If your slope is negative 5, it's positive 1/5, and so on and so forth. Midpoint, we did that earlier this year. We talked about midpoint when we were dealing with median. I probably should have lined those two up instead of midpoint and altitude, but when we're dealing with the midpoint is the average of your x-coordinates, average of your y-coordinates. And that comes into play a lot with median because it's a line segment from the vertex of a triangle to the midpoint of the opposite side. So if we ever had 2 points, we could use the vertex and a midpoint to write the equation of that line. Altitude is going to be from a vertex perpendicular to the opposite side, so that's where opposite reciprocal slopes comes into play, and we have a point. Now, when we're actually writing those equations, we had 2 forms. We had slope-intercept form and point-slope form. I think point-slope form is often the easiest one to use, and I'm perfectly happy if it's not specifically asking you for slope-intercept form if you leave it in point-slope form. Of course, if it asks for point-slope form or if it asks for slope-intercept form, make sure you provide the appropriate form. Perpendicular bisector does not necessarily go through a vertex. Remember, it is perpendicular through the midpoint of a segment. And the last 2 things to remember is vertical lines are always x equals equations. X equals whatever x coordinate or whatever your x intercept is. It is a vertical line, and therefore its slope is undefined. And horizontal lines are y equals with a slope of 0. So that's it for a quick review. I know I'm trying this thing with the video here in the corner here. You can see I've got kind of my headset on. Hopefully this is something that's useful. If not, then hopefully it's not distracting. So if it is, give me some feedback. If you haven't finished copying everything down here, make sure you pause and go back and redo that. I will move on to the next page. On this page, there are 1, 2, 3, 4, 5, 6, 7, 8 problems that are pretty much direct application of what we just talked about. I'd like you to take a minute and go ahead and try those calculations. Press pause, maybe do the first 2, unpause, the top 2, maybe then unpause it and check, then keep going on through the next sections. Alright, so for number 1, make sure that we are averaging your x-coordinates and averaging your y-coordinates. And for number 2, make sure when you are real careful with your subtraction, you're always subtracting your y-coordinates in the numerator, subtract your x-coordinates in the denominator. Minus a negative is an addition problem. Minus, so you have a negative minus a positive, it's a negative. So make sure you simplify all fractions. Alright, for the next 2, the first one I found the slope to be negative 11 over 16. I plugged that into my slope-intercept form plus the 7, negative 3 for x and y, and I solved for b, getting b to be 29/16, and then I could plug that right into slope-intercept form. I had to do slope-intercept form there because it specifically said so. In the other example, it just said write the equation. I chose to write it in point-slope form. I found the slope of the original equation by adding x to both sides, dividing by 4, took the opposite reciprocal for my perpendicular slope and plugged it in. If I solved this for y, I'd get slope-intercept form if I needed it. Go ahead and move on to the next couple problems. So these 2 used the same ordered pairs, and if we went into slope-intercept form, straight away we'd have y equals 2x minus 8. If we started in point-slope form, you have 2 options. Either one of these is correct, and you could prove it by solving them both for y. If you solved this for y, you'd wind up right back at y equals 2x minus 8. Same thing if you solved this equation for y. And for the last two, we have a vertical line and a horizontal line. If you don't see it right away in your ordered pairs that your x-coordinate was the exact same, then you would see it when you found your slope. You can't have a 0 in the denominator of a slope, or the denominator of a fraction. That's undefined. Your slope's undefined. That leads you to conclude that it's a vertical line, which leads you to conclude that it's in x equals. Go back and look, and yeah, it makes sense. X is always negative or positive 3, so x equals 3 is the equation of that line. And for the horizontal one, if you see that your y-coordinate was the same, you can go straight to your y equals negative 7. If you don't see that the y-coordinate's the same, you're going to see it in the slope. The slope is 0. That's a horizontal line, or a y equals. Alright, and then the last set of problems I have for us is to talk about this with triangles. So, I will also be posting a sheet with a bunch of graph papers on there, so you guys, if you need access to some extra graph papers, you can print that off if you have access to a printer at home. But we'd start by plotting our triangle, and the first trick is to recognize that if we need the median to AB, that means we are looking for the midpoint of AB. If we can find the midpoint of AB, we're going to use the opposite vertex, C, and that midpoint, and write the equation of that line. Go ahead and give that a try. So hopefully we find our midpoint here. I'll label that point M, and now we're looking for the equation of the line CM or MC. So we need to find the slope, and we can either just write it in point slope form, because it doesn't specifically say, or figure out what that would be in slope intercept form. And through the magic of video, I've corrected all of my mistakes, plotting point A wrong and then calculating midpoint wrong. So kids are screaming in the background. They're a little upset with my mistake as well. I apologize for that. But I'm going to do slope-intercept form, and the reason I'm going to do slope-intercept form, and I encourage you to do so the rest of the way today, is it's going to make some things a little bit easier as we get into them tomorrow. So I found the rise over run without even doing the calculation. I looked at M to C and noticed I went down 7 units and to the right 4 units. That's a slope of negative 7 over 4. Then I plugged into using the point C, and I could have used my midpoint as well to find my y-intercept. And now I have my y equals negative 7/4 x plus 14 in slope-intercept form as the equation of my line. See what you can do with the rest of the problems on this page. Alright, for part B we use the same midpoint, but now I need the slope perpendicular to segment AB, so I find the slope of segment AB, take its opposite reciprocal, use that slope plus the midpoint that we're going to be going through to find my y-intercept, and I've got my equation. And for part C, again, we're perpendicular to segment AB because it's the altitude to AB, but we're using point C, 80, since that's the vertex opposite segment AB. Using the negative 6 slope and the point 80, we've got our new equation in slope-intercept form. One left. So Blake's got to tell us something. What do you got to tell us, Blake? Do you know what that equation is? Does that say? What letter is that?
Y.
Is that? That's 1 over 6. 1/6. What letter?
X.
Minus 4 over 3. We're going to try to do some geometry and algebra with Gavin and Blake. Say hi, guys.
Hi.
All right. If you guys have questions, shoot me an email. Hope everything's going well. Hope everybody's staying safe. We've been doing a lot of stuff with these guys, so hopefully you guys are having some fun along with doing some learning. Take care.